This is a beginner's guide to weldments. I'm going to be really clear about this. It is a beginner's guide, guys. If it is something you're looking for that's more complex, above and beyond, I have no problem answering those questions during, when we get to that point. I'm also more than happy to hang out a little bit afterwards if anybody's got anything specific. So I am there for that, but this is definitely a beginner's guide. Kind of, I've played with it and I have no idea what I'm doing, or I've tried and it kind of worked. So it's going to be kind of like that. But again, if it's something that's more complex, more than happy to address that after the fact. So let's go ahead and get going with our slideshow here. And I promise you, not a lot of slides, more show and tell. So here's kind of the key takeaways that we're looking at today. One is just kind of getting started. Anybody who's ever launched Weldments, you may see that you get this kind of like short list of options. I've got these 2 standards, I've got a couple of types and maybe a couple of profiles underneath, and you're like, well, what's going on with that? We're going to talk about how to get more out of that. We're going to take a sketch, basically start with a 2D sketch, and we're going to work that all the way through a 3D sketch into making a drawing, getting a cut list, and inside the drawing, ballooning, all the fun stuff there. And then we're going to look at other uses. It's not just for structural steel anymore. It never has been, actually, but a lot of people find that limitation. So we're going to look at that as well. So it's going to be the main 3 takeaways that we're going to look at. So let's talk about just a quick introduction about me. I have been a Solidworks user since 1997. If that says anything, it came out in 95. So I've seen the growth and I've seen some seriously cool things, especially when it comes to areas like weldments. I joined Fisher Unitech, which is a reseller, in 2007, and I joined the support team in 2010. I actually did spend 3 years of doing tech support, as crazy it sounds, for the fun of it during those first 3 years. And when they gave me a choice if I wanted to do pre-sales or post-sales, I decided I wanted to help you guys after you bought the software. So I joined the tech support team and I started managing the team in 2017. We merged with CATI in 2019, which has been a great experience overall, especially for the support team. And I became an elite AE in 2019. And yes, it took me a really long time to get there. I took my time. All right, so a little bit about me. Here are my specialties: is I love sheet metal, weldments, and surfacing. And yes, my husband thinks I'm a total freak because I'll get into, a watering hole someplace and start having discussions about things like this. And he just shakes his head and walks away from me. I'm an avid Brewers and Packers fan, as you can see, and there's my beautiful family and, of course, my hero, Aaron Rodgers. I enjoy the 2 seasons in Wisconsin, pool and softball, and, of course, year-round fishing. So that's enough about me, and let's get on to what we're here for, right? So let's talk about getting started. What are weldments? Basically, the idea is weldments allow me to design in a part level using multi-bodies, using 2D sketches, 3D sketches, which defines the framework or the skeleton of what I'm working for. And then when I start to add those weldment features, and what's really cool about this is that as I create these weldments, I'm not just stuck using weldments. I can use weldments, I can use parts, I can use sheet metal and combine that all at a part level. And we're also going to talk about why that's an advantage a little bit later on as well. So kind of covered about what weldments are. So let's talk about the beginning here. Why aren't there more? Where are they all hiding? How do I get access to them? We're going to look at that. And we're going to talk about the folder structure, which, as crazy as it sounds, is actually really important here. So we're going to switch on over to Solidworks for a moment and say, okay, you guys have launched Weldments. You look at it and go, yep, okay, I've got this cute little list of, just a few types, a few options. Where are they all hiding? They're actually in your design library here on the right-hand side. Underneath Solidworks content called Weldments. And basically what these are is these are just zipped up files of all these different types of, ANSI and ISO and all these different types of standards that are out there. So how do I get access to these? If you hover over any one of them, you can see it just says, look, hold control and click to download. So if I hold control and click, it's going to say, okay, where do I want to save them? All right. So I happen to have mine on my D drive here. I'm not going to download this. I will tell you it's pretty quick to do. In the old days, it used to be a good couple of minutes. It's usually 30 seconds or less, but I'm not going to waste your time with that. But what you're going to see here is that I created this Weldments profiles folder for myself. Also notice that I don't have it buried really deep. I'll talk about that a little bit more in a few minutes here. But then underneath, you'll see, actually, it's probably better if I go this way here. We're going to go this way. So I'm not going to save it, but you'll see this Weldments profile here, and you're going to see there's my zip file right there. All right. So I want to unzip it. Be very careful. Windows is trying to help us out here. So if I do an extract all right now, by default, it's going to want to add my anti-inch folder. It already exists. So if I hit extract right now, it's going to create a folder called anti-inch, and underneath another folder called anti-inch, which is going to cause problems. So when you're going to do the extraction, guys, just get rid of this. Just go in, delete that, hit the extract. How do you know you got it right? Because you should see your anti-inch folder, and when you double click it, there's all the standards that come with it. Now again, remember, we kind of talked about that short list that's there, right? Here's this nice long list, and just, for grips, aluminum tubing. There is all the different profiles. Now you know why this stuff is zipped up, guys, right? You imagine you guys have all wondered about why Solidworks is so big and why it takes so long to install. Can you imagine if it extracted all of this as well for us for each of those standards? Nobody wants to go through that. You'll notice that I have multiple. I just happen to have, I did Unistrut here. I went ahead and did ISO. So I've got those all set for myself for different scenarios. So I'm only going to download what I need. You're also going to notice I have this one called lumber. That's pretty simple. And we're going to get into that a little bit later on why that doesn't have kind of that dual level going on that the rest of them do, where I've got the standard, then the type, and then the size. All right, so I've done this work. Now, how do I tell SolidWorks where to go? Now, I know everybody wants to tell SolidWorks where to go once in a while. This is where we want to tell it where the weldments are living. So you're going to go to your options, right up here. We're going to go to File Locations. And we're going to go ahead and go all the way down to Weldment Profiles. And you want to make sure you're at that top heading. If you go any further, if you go in and browse to the anti-inch folder or anything else like that, it's not going to work. So you want to make sure you're at that head profile right at the very top where everything else is living. Now you're also going to notice SolidWorks has a default location. That's where that original kind of small stack of items come in. So that's where that's originating from. I will tell you from experience that older versions of SolidWorks, if this is here, when you try to do a structural member, you're not going to see your other list, even if you try to do something such as like move it up. You may have to delete that. So if you're not seeing the full list after you've downloaded and you know you're pointing in the right direction right here, make sure to get rid of this. I did notice in 2020, it looks like it's finally resolved, but I'll say for, I don't know, the last 10 years that I know of, that's been a problem in the past. So if you are not seeing that full list, just go ahead and get rid of this and just have this your only location. The same thing goes for guys, if you're going to work in a network environment, if you're going to share profiles and that type of thing, because why have 15 people download the same files, right? So you're going to want to put it someplace on your server. Do not bury it down. You want to make sure that it's not 15 miles down in a folder. Try to keep it as high in the root as possible for yourselves, and then just have everybody point to it. All right. So I'm going to go ahead and just cancel out of that for a moment. And we're going to go back to my PowerPoint super quick. So what did we cover? Just a quick overview of what are weldments, and we're going to talk about that again as we go on. Why aren't there more? Folder structure, and of course, yep, why am I not seeing them yet? And you can see there's my cleaned up version of that where I just have my Weldment profile folder. All right, so now that we kind of know the basics of how to get what we need, let's talk about how to work with it. So this is taking things from a sketch to a drawing. I'm going to talk about 2D and 3D sketching. I'm going to talk about the Weldment feature itself and looking at the multi-body design inside of a part. We're going to do a quick overview of the cut list, and then we're just going to take a quick look at a drawing. So I'm not going to make you watch me design all this stuff, so you're going to see me start things and then kind of bring up finished product, that kind of fun stuff. So we're going to go ahead and start with here. All right, so I want to create that skeleton, that framework, right, to start with this. And right now, all I've got is a simple 2D sketch. What I want to do is I want my sketch to also live here, and I want it to be the same. So for those of you that are looking by your names, you can notice you got some icons. You got a green check mark, you got a little X, you got a little emojicons there. You can put up a cup of coffee if you're bored, whatever it might be. That's fine. I'm going to ask a question. And the question is, how many of you are familiar with using convert entities? So if you can hit that green check mark, I'll give you just a couple of minutes here. Just hit that green check mark and say, yep, I've used this before. All right, couple people maybe. No, we got a list of 98 here. I haven't scrolled through everybody. All right. So, okay, convert entities would work here, right? I can select on this plane. I can launch a sketch. I can select my 2D frame and convert it. All right. So convert entities is pretty cool. And basically, here's what a convert entities does, guys. So people who've never tried it or never heard of it, you are missing out on the coolest tool ever. Convert entities allows me to project sketch slides, sketch entities, edges of parts, whatever it might be. It might be a hole, and project that image or that entity onto a new plane. So just to show you what that is, I'm going to go ahead, and to do this, you do have to launch a sketch. So I've got a new plane here. I'm going to launch a sketch. I'm just going to pick on this line here. I'm going to go back to an ISO for a moment, and I'm going to do this convert entity. So that's what it does. Okay, cool. It's very cool. Here's the problem with this scenario, though, in my case, though. What if I have to make changes here? If I delete this line, you'll notice I have a relation right here. And if I look at this relation, it's actually called an on-edge relation. Now, again, I can do this with entities. I could do this with a whole edge. So say I had a hole in a plate and I wanted to project that onto another face, convert entities. It's beautiful, right? But here's the problem. Again, any changes I make could adversely screw this. Okay, I'm going to say it, screw it up, right? So if I get rid of this line's going to go, well, I don't know what I live on anymore. You got to fix me. So I'm going to show you an alternative. And this is the most underused sketch tool out there, and it's called a derived sketch. And a derived sketch says, I want you to replicate what I have, and I want you to project whatever that sketch is onto my new plane. I want the same thing. And basically what I'm saying about this is not only do I want all these sketch entities, but I want everything that's driving that sketch. If I just double click on my 2D frame now, you're going to notice I've got a couple things going on. I wanted symmetry. I wanted to be able to change this dimension only. I'm going to go from 108 to say 160. And I'm going to rebuild it. I want everything to move with it, right? So I've got these beautiful little equations in there to say, hey, whatever this is, here's a third of it, here's double of it. So I'm using some intelligence in the sketch. I'm going to go back to that 108. And again, when I do it here, I do have to rebuild because I'm not editing the sketch. And now it brings me back to my original. So what I'm going to do is this derived sketch. To do that, I'm going to pick on the frame sketch here that I named. I'm going to hold control and I'm going to pick on the offset plane. So I'm basically saying I want this sketch, I want this plane. I'm going to go to insert and I'm going to go to derived sketch down here. Right there. Let's see. There we go. Derived sketch. Is a complete replication of my original sketch. Notice no dimensions. Don't care about the dimensions. My dimensions are all being driven from here. Notice it moves as one piece. It's on that offset plane, but it's one entity. I'm just going to add two quick relations to lock its orientation here. So I'm going to hold control. I'm going to select these two back end points, and I'm basically going to tell them that they're coincident to each other. All right. So I'm locking down saying, if I were to rotate this normal too, locking it down saying I want those endpoints to be coincident to each other. Notice now that endpoint's locked, but you can see I can still swing this around. I'm just going to do one more. Holding control, I'm going to select these two front endpoints and make them coincident right over here on the left as well. And I'm locked down. That's it. That's all I need. Now, what's important about this? All right, I'm going to go ahead and get out of this for a moment. And there's my two sketches. So, like I said, convert entity. Some of you didn't realize what it was and went, oh yeah, I've used that before, right? But the question is, have you used this and why do I want to use it here? Well, I want to make sure that anything that goes on in that front sketch goes everywhere else, right? And what does that mean? I'm going to make a change to my 2D frame here. Now, granted, in a situation like this, I probably wouldn't be adding a circle, but just for experience or just for, the way of looking at it, I've added a circle. I'm going to go ahead and close out of the sketch. I'm going to go ahead and go back to my ISO, and what do you see? Anything that goes on that original sketch, I change a dimension, I delete a line, I add an entity, will propagate to that derived sketch. So again, takes away, I'm thinking about things, right? I don't have to think about anything. Anything that happens on that first thing is going to happen on the second thing, which is exactly what I'm looking for. So I'm going to go ahead and just get rid of that circle. Close the sketch, come back, and boom, there we go. This is the advantage of doing a derived sketch as opposed to a convert entity. So big fan of this. All right. So now I've got these two 2D things. And when we talk about creating weldment frames or skeletons, it's really about how do I want to design? You can design in 2D. You could design in 3D. You can design, or 3D sketching. You can design in both. You can have a hybrid sketch going on right here. All right. Now I did a little bit of cheating just to let you guys know here. And if you'll notice, I actually added some points onto my sketch right here. And the reason I did that is to help me in my 3D sketching to kind of connect the dots. Because what I want is I want to create a 3D sketch here that's going to go from one frame side to the other. It's going to go ahead and quickly hide out that plane there to give you a little bit better visual. Okay. So I'm going to go ahead and get my line tool, but before I do that, I need to get into my 3D sketch. So I'm going to pick the 3D sketch. I'm going to get my line tool. Now I'm not going to draw all of this, guys, but just to give you a feel for it. I'm going to connect the dots. I'm going to go from point to point. Point to point. Just double clicking off to the side to stop that, and you can see I can now use those points that I created. And I can easily add all of my lines in between to create my full structure. Keep in mind that there is an advantage to this because it is symmetrical from front to back that allows me to do this. All right. And of course, what I would do is I would go in and add all of my other sketches. Not going to bore you guys with doing that. Hopefully you get the feel for what I'm doing here. All right. So when I'm done with that, I would have my original 2D frame. I would have my derived sketch, and I would have my 3D sketch. All right. I'm going to go on to a finished sketch just to see what I did here. All right. So there's my frame. All right. Now I can start working with my weldment. So my weldment, if you're not seeing it in your tabs right here, and it does depend on what version you're doing here. In 2020, they actually have it underneath these tabs here. I think in the earlier versions, if you just right click, it's kind of a list. But I just want to go to tab and make sure my weldments are turned on here. I'm also going to be working with sheet metal, so I have that live as well. So let me get myself started. I'm going to go to weldments. And by the way, guys, there's absolutely no reason to click this icon. I'm going to let Solidworks do that for me by just starting with a structural member. Simple as that. That's going to add that weldment feature, and that's going to help drive how my tree is being built. All right. So if we take a look, there are all those standards. So those are all the standards that are underneath that weldment profile folder. I'm going to stick with ANSI Inch here. You're going to notice all of the types that I have, and I'm going to go ahead and just do some square tube here. And then I can go ahead and pick my size. I'm going to go with a 4x4 by 0.3125. So that 0.3125 is just my thickness of my material. So I'm going to go ahead and pick that. And now I can start selecting entities. And what's really cool about dealing with weldments is, I'm sure you guys have run into this. I'm trying to design, an extrude. And I got all these, I've got all these construction lines to help me get the shape going on or whatever it might be. In weldments, it doesn't care. I could have lines, I could have points, I could have circles, I could have all sorts of stuff that I may be using for reference that I'll never select, and it will not hurt because I'm not trying to use this sketch to actually extrude a physical being. I'm not taking this outside border and trying to extrude an L, right? I'm just trying to use this as a frame. So what I have now are groups. So what's a group? A group is a set of entities that I've selected that I can put together. And there's a little bit of a rule when it comes to creating groups. Groups can be as long as things are, say, parallel to each other. So just to start here, I'm going to go ahead and just select on. There we go. We're getting our preview here. I'm just going to go and pick all my little vertical lines, right? Perfect. Now I'm going to get into a little bit of the details a little bit more, but what I want you to notice is, here's all my past segues, right? But notice when I try to pick this, it's not letting me. Basic rule, no matter what you do in SolidWorks, probably one of the first things that you'll ever learn. If you do not get a preview, SolidWorks is pretty much telling you it's not happening, or you don't have the preview turned on, one of the two. In this case, it's telling me it cannot accept my new selection. But because I am working in the same size, what I don't want to do is I don't want to hit OK here and start Weldments over for my new size. What that's going to do is it's going to force me to start having to manually trim things. Now I'm going to get into a situation later on where I'm going to show you why I'd want to manually trim something, right? But in this case, I don't. What I want to do is I want to start defining these outside frames. So basically, I'm going to define these outside frames. And a little bit later on, I'm going to come in with a different size, and I'm going to create these kind of braces in between, right? But before I even do that, I'm going to come on, sneak on down here, and let's see what kind of options we've got here. All right. If you've got a profile that is not a square, you can mirror the profile. So maybe the orientation isn't right, so you can mirror it. You can see that you could choose to mirror along a horizontal or vertical axis. I can also give it some sort of angle. But what if right now it's not kind of living where I think? So here's a little bit of pre-thought when it comes to making that skeleton. Is that skeleton defining your OD of your part, your ID of your part, a mixture of those two, or the center? For ease, I used my sketches to be the center. But what if it's not supposed to be? I can come on down and do what's called locate profile. It is going to take me to my very first selection and say, okay, you could see by default that this profile is living right smack in the middle. Typically, this is going to be where the origin is on the sketch. And a little bit later on, we're going to actually look at what one of those sketches looks like, right? But it's pulling up from the origin. So by default, it's going to go in the origin. But what if I decided, well, no, that little sketch line, that vertical line is supposed to be my OD of this weldment right here. Any one of these points, and that could be a point that's been added by a construction line. It can be a vertical sharp. It could be a center of an arc. I can choose a new location. It's going to switch. Now, something to keep in mind, I'm just going to back up a little bit here. Notice it changed all of them, right? Now, if the case is that it's supposed to be my OD, I would have done these four, started a new group for these four, and changed the profile to be in, if that makes sense. So notice they all moved at the same time. That is because I'm doing all 8 at the same time. So a little bit of pre-planning on that, how that frame is going to drive your location of your weldments is critical. How am I going to use it? And again, like I said, if the idea is these are supposed to be on the inside and they're not, I would not add those 4. I would only do these front 4, and I would do a separate group for those. In my case, though, it is center. So I'm going to go ahead and just go back, pick on that center point right there, and it's going to drive itself back to the center of my lines here. So if you take a look at this, it's kind of what I was talking about before. What's really going on with a weldment is all of those files that you extracted, all of those profiles are basically a sketch. And basically all I'm saying to do is I want you to sweep that profile along the entities I pick, basically my frame. So that's all it's doing. All right. Now, I could certainly hit OK here. And like I said, start my new group. I want that to be at the top. But if I do that, I'm stuck doing a lot of manual trimming. Don't want to have to do that. So I'm going to do what's called just a new group. And I'm going to just start picking here. And I'm going to go ahead and say, yep, anything's connected. All right. Now, I don't know about you guys, but the corners look pretty crummy, right? Not quite what I am looking for. That's what those beautiful purple dots are for. I'm going to go ahead and just pick on this one right there. And you're going to notice that it is talking about my corner treatment and how do I want to do it. You can change the trim order. So I'm just going to go ahead and hit the up arrow. And now you can see that it's mitering all those corners for me. I'm going to just hit OK for a moment. Now, before I go any further, if you look down at the bottom here, you'll notice that per group, I can determine how I want those to be. So it can be a miter or an end butt in either direction, right? Notice I can mix and match. Typically, I would go around to all four corners though and change the trim. And again, you could see that I get those mitered corners. I'm not going to waste a lot of time showing you how to do this, but for my next grouping, I'm going to go ahead and say new group again. And now I'm going to go ahead and pick on my next four. Make sure I'm not getting the wrong lines here. And what you're going to see is how it's auto trimming. So notice my first selection, those first 8 entities I picked, any selection I make off of that is going to start trimming up those entities for me. It's the reason I didn't start a brand new feature for the same size. I'm letting SolidWorks do work for me and say, look, I want this first. I want you to trim. So order matters. All right. Now, I need to do the next one. And again, I'm not going to spend a ton of time. I'm going to pick on these 4. You could see the trims. And then I can go ahead and one last group and pick on these 4 on the bottom here. And even on the bottom, you can see, whoop, hold on, lost my headset. There we go. All right. Again, dealing with the corners, I can change the order this is trimming. I can say, hey, I want this bottom piece to be full, or I want this to be full, and I want you to trim up the pieces. That's all going to be up to you. All right. So, again, this is not my finished problem. Well, it might be my finished problem. So this is my finished idea, but again, I'm not going to waste your time with a lot of stuff with cleaning it up. I'm just going to go to one that I've already cleaned up here. And there we go. So you can see I've mitered the corners, right? It all looks pretty. I've determined that I want these bottom ones to be full, but I want the mitered corners there. So I did that cleanup, right? Now, if we take a look, that is one feature in my tree. That's it. All right. Now I want to add a new size. I want those braces to be smaller. And you can see I've got those 1, 2, 3. I've got those 5 right there. So this is going to require. Now I can change the size. By the way, if I edit this feature, I can say, well, that should have been a 4x4. This should have been a 6x6. It will all update for me. But I need a new size for the brace here. So that is going to require a second structural member. And I'm just going to go ahead and change this tubing. We're going to go ahead and do a 2x2 by 0.3125. And where's she hiding? I know she's around here somewhere. There she goes, right there. So same material thickness, just smaller. So because these are all parallel, I should be able to just go down the line. And again, I'm not going to mess with the profile location. I'm just going to pick those 5. But I also want you to know something. It is being embedded inside. Because right now, with this being a separate feature, it's not going to go, oh, well, you know, hey, you've already got this model here. Because it's a different size, it says, no, I'm just going to use the entities. And if you remember the way my entities worked, they're all kind of in the middle. So this is going to require, once I hit OK here, this is going to require some cleanup. All right. Cleanup is super simple. I'm going to come on over to my trim extend here. And again, I'm not going to spend a lot of time doing it all, but we're going to go ahead and pick on that. And what body am I trimming here? I'm going to go ahead and pick those 2 because they are being driven by these 2 ends right here. So those 2, you can use a face, you can use a surface, you can use bodies. So that's what these all are. These are all individual bodies. We're going to take a look at the cutlass in just a moment to kind of look at that. So I'm going to say, I want you to trim using these 2 bodies. And so now it's going to go ahead and trim that up on each of these sides. Right. I'm going to go ahead and hit OK there. I would do the same here. We're just going to do the trim one more time here. And actually, I could have done this a little bit better and picked that one as well. But we're going to go ahead and just trim these 2 bodies here by, let's see if it lets me do it here. Aha, that's what I should have done. There we go. Do as much work as possible in one command, right? So I'm going to go ahead and hit OK there. And I'm just going to fix this one trim. We're just going to add a little bit here. I'm going to say, you know what? Let's go ahead and pick this. I'm going to go back and add these two bodies as well. Again, let SolidWorks do some work for me. A couple things down here. Again, you can see I've got the preview on. This allow extension. This is basically saying how this is driving. Now, in this case, you can see that my profile is smaller than the face that it's hitting. So even if I were to tell it to cope, it's not going to do that, right? I'm just going to say, yep, trim it up as nice as possible. You can also add weld gaps here. So if you know that you need a little bit of clearance for a weld gap, here's where you can add it. All right. So now that I've got this, I want to just take a quick look at my cut list real quick. Currently, you can see I have 35 bodies, right? So there's my 35 bodies. And what they're doing is they're putting like sizes together. These have to be identical to each other, all right? Any difference in them. I add a hole to one of those bodies, and it's going to take it out of its list and say, nope, it's unique, right? Just to give you an idea on that. But you can see how it's put everything together. So there's my original structural frame here. Now what I want to do is I'm just going to add a plate. Right? All I want to do is I want to add 3 metal plates. Again, not going to waste your time with how to add a bunch of plates. I'm going to add one and show you the results here. So how do I do that? I'm just going to start a sketch here. I'm going to go get my rectangle tool. And I'm just going to start with this face right here. And I'm just going to go ahead and basically going from a point here. See if I can get that point right there. There we go. Oh, let's not use the center one. How about that one? There we go. I'm going to go from point to point here. So basically, turn off my rectangle tool for a moment. Basically, what I want to do is I want to use my framework here to help define the size of my plate. So this may require me to add a little bit of relation here. I might turn around and say, whoop, let's go to a normal 2 for a moment here. I might go ahead and say, you know what, you, that point I'm holding control, need to be coincident to this edge right here. And make it coincident. And then you can see how that's starting to lock things down, right? And you can see this one moves. Maybe I'm going to say you are, see if I pick that edge, pick a line, say you two are collinear to each other, whatever it might be. I want this to be a sheet metal plate. Now I can certainly extrude this, but I'm going to miss the properties that come with being a sheet metal plate. So instead of just going to features extrude, I'm going to go to sheet metal. And I'm going to say I want to do a base flange tab. Okay. So a couple things I need to look at here. One, make sure I'm not going into the model here, which I don't want to do. So I'm going to go ahead and reverse the direction. I may decide to go ahead and use some sort of gauge table, and not going to be a sheet metal seminar here, but maybe I'm just going to say, yeah, I want to go ahead and make this, maybe some steel going on. And I'm going to make it, oh yeah, let's go ahead and make it some 10 gauge there. And let's go ahead and reverse the thickness. Oop, reverse the thickness. This is where previews come in, guys. Reverse the thickness so it's going up and over. Probably the most important thing here. I'm not merging the result. I do not want it merged with the weldment. It is not one piece. It should be its own body. So once I go ahead and hit OK, it's going to go ahead and add, and what you're going to see here, it's going to add a sheet metal part and track it. Underneath, you're going to see there's the body. So going to my next step here, as you can imagine, I built a bunch of plates. And there's my end result almost. I didn't want to go to the drawing quite yet, so we'll just go ahead and swap open to the open part here. All right, so there's my plates. So a couple things about the cut list. You'll notice that it's calling out the profile. I'm going to go to my options here. And I am going to go into my document property. So this is tied to the template I use, the part template I use. So if I change this here, it's only going to change it here. If this is going to be the standard for how you want to work, you'd need to save off the template. Open the template, make this adjustment here, and save it off. So if you take a look at Weldments here, I've got a couple of things turned on. Automatically create cut lists. That is what's driving creating this information to begin with. Otherwise, all I would see was a folder with multiple bodies. Rename the cut list folders with description property values. I love this one. If I do not do that, these would be called item 1, item 2, item 3. As you can imagine, makes a whole lot of sense, right? You know exactly what that means. This at least tells me what size I'm dealing with at this point. So I'm allowing that to happen. Automatically update cut lists. Notice this little note, may affect performance with many bodies. If you're drawing a structural steel building, guys, I wouldn't recommend having it automatically update the cut list. You may want to just turn it on once in a while to have it rebuild, but I wouldn't recommend working with it because, as you can imagine, the more multi-bodies that a file has, the more multi-bodies that it's got to rebuild and deal with, right? So making sure of that. This is also driving right here for sheet metal. By default, any sheet metal part I make, and this includes making sheet metal itself, any sheet metal by default has a description called sheet. So where does that information come from? So here is my tree right here. And the other thing I want to point out is I did give my frame a plain carbon steel, and that is for everything. What I want to point out here is that I added steel to my plates. So underneath, it was giving me problems before, guys. Just giving you the heads up on this. If I were to select these two tubes right here, notice I'm selecting the bodies underneath. If I right click, go to material, yeah, my material's not working there. I don't have any idea why. I've got something hiding somewhere, guys. But I could switch those materials. So I can have individual materials for these bodies. Why do I care? Because I want that in my cut list later on. I want to be able to define what materials each thing is. So I can have my main material, and that's kind of how I think about it. Whatever's in that tree is basically what is the majority of the material for the entire file, for the entire part file. But if I need to change individuals, I certainly can. If I accidentally only change one of these, even though these two are the same size, it would split up and make another sheet for me. So I had to make sure to select both of them, tell them I wanted to change the material, and I applied this ASTM A36 steel to it. All right. Since we're in here, let's talk about those properties. So what all comes with all the information that we've got going on here? On any one of these items, I can right click and go to properties. So got 3 tabs going on. First of all, we have this big long list of things that come with it. We have length. That is the length of that body as is. I don't have any angles cut into it. I don't have any 45s or anything else going on like that, so you won't see that there. I haven't driven any sort of information about the angle, so I've got nothing there. The description. Notice it's the only one that's white. That's the one I can change. But right now that is pulling from the profile, and these are default inside the profiles of the files that you've extracted. All right. Material, you can see there's my plain carbon steel. You're going to see a quantity, and then you're going to get the total length. That total length is going to be the total length of every single body that is the same size. So all of my 4x4 by 0.3125 totals this much material. So even if I were to pick on a different one, you'll notice that my length changed, but my total length did not. All right. So here's all my weldments. And if I come on down here for sheet metal, notice there's a lot more going on, right? But one of the things that it doesn't do is give me this description. So I'm certainly going to want to come in here and modify that information for what I wanted to build. I'm not going to waste my time doing it for you guys, but just so you know, here's where I change it. But all of this other information about this comes in as well. So anything that you're seeing in these lists can be propagated to the drawing for the cut list. All right. So I get things such as the bounding box length and width. Well, this isn't really a shocker here that they match the size of my plate. There's no unfolding or flattening going on here, so it's not going to have any effect on that. All right. Promise I'm almost done with this, guys, and then we're going to definitely give you time with questions in just a few seconds here. All right, so that's all the information that can be there. I'm going to go ahead, and one last thing I want to show about this. You guys may talk about this. Why? Why did I do this as part level? Why don't I just build all the and build it? If anybody's ever tried to build what's called in context at an assembly level, you have top down and bottom up assemblies. Bottom up is I built all my components. bring it together in the assembly, piece it together with my mates, and make my assembly. Top down says I'm using information from one part to help build another part. So picture in your head a plate that you bring into, so just a rectangular plate, stick into assembly. And I want to build a plate on top of it, and I want to steal the holes from my original plate. I can build in context a new part at that assembly level and steal information, kind of like that convert entity type thing going on. I'm going to take this hole and I'm going to project it onto my new plate, and so the holes match up. It's great. But if you've ever done that before, there's problems. You forget to save the assembly off, everything that's related to Assemb1 or whatever assembly you're on. Then when you try to rename your assembly, it goes, well, no, I've got all these parts that are associated to Assemb1. By the way, you ever run into that, your solution to that is pack and go. Do a file, pack and go, rename the files, maybe put them somewhere else, but rename that assembly file, and all of those in-context relations will update to that new file. The only way out of that one. There can also be the possibility of creating circular references. I've seen that a lot. Turn around and it starts yelling at you going, well, am I being controlled by this or am I being controlled by this? This eliminates that. So right now, to drive this entire size, I have three things going on. I have my 2D frame size, right? I got that 108 right there. And I've got the offset of the 48. Those are the two things basically driving everything about this. What if this thing was supposed to be, I don't know, 96 inches wide? So still in the part file, I'm going to go to that offset plane. I'm going to change it to 96. And I'm going to rebuild it. Control Q. That's the beauty of it. That's why I built it like this. So any change I make to these dimensions, everything is going to update for me. That's exactly what I'm looking for. I'm going to go ahead and just for grins, let's change that 108 to be 154 and rebuild it. Boom. There's my changes. See how quick and easy that is. Put in that upfront work, a little bit of thought process into the sketches, and you can see where I can go from here. All right, just for grins, I'm just going to do a quick change back here. Well, you know what? We're just going to do a quick file reload here. And by the way, if you ever do a file, maybe you're like, whoa, I didn't want to do that. If I do a file reload, keep in mind, it's only going to take it back to the last time I saved it. So you want to be careful with this. But if you're ever going to try something where you're iffy about how the results are going to be on a part file or an assembly file, save it. If you make a mistake, if it blows up your tree or does whatever, do a file reload, and it will bring it back to its original. All right, so very quickly, the drawing here. So there is my sheet. I'm going to go ahead and bring in my cut list here. So I'm going to pick on this. I'm going to go to that table. I'm going to bring in a Weldment cut list. By default, one already exists. So I'm going to go ahead and just accept that. And I'm going to pop it in there. Notice I'm getting my descriptions. I'm getting my legs. Anything that's part of that cut list, like I said, can be here. So say I want a material. I'm just going to go ahead and insert. Let's see if we can get an insert going on here. Let's go ahead and insert a column to the left here. And I'm going to go ahead and take a look. Notice there's a user defined. What I'm looking for is the cut list item property. I'm going to pick that up. I'm going to go ahead and say, I want material. Hit OK. And that's going to pull all those materials. And you can see there's my plain carbon steel. There's my ASTM A36 steel. All that information is in there. And of course, if I want to just balloon this, I'm going to go ahead and pick on this. I'm going to do an auto balloon. It's going to grab all my item numbers. I'm not going to get fancy with this. I'm just going to allow it to be what it is. And that's going to match up with my item numbers. Now, a step above this is, what if I do have something unique? I've got these kind of funky looking cuts, these mitered corners, right? How do I show what one of those looks like? I can do this with any drawing. So this is going to eliminate the need for me to make its own part file. And by the way, that is, everybody's like, well, can you save those out as part files for the bodies? You can. Whole another half an hour discussion I'm not going down. So just let you know right there. Hang out afterwards to answer questions, but yeah. All right, so if I do need that, inside my drawing tools, my view layouts here, I have what's called, and where did it go? Let's see, we're gonna go to Insert, drawing view. I want to go to what's called relative to model. So I'm going to go ahead and pick on this, and it's going to say, okay, pick a face or a plane or a model that I want to work with here. That's just my model right here. I'm going to go ahead and pick on that. And it's going to say, okay, what are we doing here? I can do the entire part. I could do a selected body. I'm just going to do a simple selected body. And I'm going to go ahead and pick on this body because I know I got that funky mitered corner right there. And now I can define kind of how I want that orientation. I can define the front. Maybe I say this is, go ahead, we're going to say this is the front right here. And oh, for grins, we'll just make this the right. I may have to do a little bit of orientation at the drawing. So I'm going to hit OK. Now at the drawing, it's going to pop me back here and allow me to drop in. This is probably not the best place to do it, guys, right? But maybe I have a second sheet out here. And I can get that view going on. Maybe I want to go ahead and project a view from it. Sure, let's go. There we go. Working a little slow today. How about we go this way? There we go. All right, projected views. All right. So we're getting close. I got 10 minutes left, so I'm going to move on. But again, you get the idea. As everybody knows, drawings are probably the simplest idea of what I can do with all this, right? So I'm going to go ahead and go back to my session real quick. What did we cover? We talked about going from 2D sketching, 3D sketching. We talked about a derived sketch. We looked at some weldment features and adding additional multi-bodies like sheet metal. We talked about the cut list a little bit. We talked about drawings. So not going to show you all this, but just give you an idea here. Other design uses. You have the ability to configure a profile. Again, because I'm kind of talking lumber. So I'm going to show you a quick example, but I'm not going to go through the whole building process of this. Building a wall, packaging, and even cabinetry. So these are all different scenarios that I can use to use weldment profiles. So if I go back here, just so you know, here is my weldment. And one of the cool things, and just letting you know, if you ever want to make your own weldment, feel free to open up an existing weldment. It is an SLD LFP, library feature part right here. Open one up, save it off of something else, and make it your own. All you have to do is go edit the sketch. It's already understanding that it's a library feature part, and it's going to work just like all the other profiles. So much easier than starting over, just letting you know. All right, but if you can see in this scenario, I basically created different sizes of lumber. What that allows me to do is I'm going to go over to the fence here. And again, I'm not going to build it, but you can see that I used lumber. I'm going to go ahead and edit this just for a moment because I want to show you the difference. So I have a folder under weldment profiles called bar stock. I went ahead and there is my configured lumber. And there's all the sizes calling from that. All right. So I've done that. I was playing around a little bit. I did a different size for the smaller ones. I can actually go out and pattern something. Just to note about patterning, when you are patterning something, it is critical that you're patterning the body. You're not patterning the weldment. So if I want to pattern something, I'm going to pattern the body. So I patterned it, and then you can see I did a little bit of trimming up here. So again, just the idea of using this picnic table, shed, whatever I might do. Beautiful way to use lumber. That other scenario, packaging. Again, not going to show you how to do it all, but same kind of idea here. I used some configured lumber. I did some boss extrudes to create the panels. Did some mirroring, all that kind of stuff. And yes, I had the fun of, making it wood just for grins and giggles here. But again, the idea of packaging and letting my sketch drive everything. And then that last scenario for cabinetry. Did I not open up the cabinetry? Let's see if we got the cabinetry, guys. Cabinet. There we go. This one I thought was kind of cool. A little bit different here. I just did a boss extrude, I shelled it out, cut out some holes, added some thin panels and extruded it. And then I had and actually used a weldment profile. You can see right here. This was actually an L angle. I took an L angle and modified it to add kind of some unique profile to it. And I actually used that to create some crown molding. So just some different, I did see a comment here about corrugated cartons. If I was doing corrugated cartons, I'd actually be using sheet metal so I could unfold it. So sheet metal would be where I would use that as opposed to weldments. All right. So we talked about different types of profiles, building a fence, building packaging, cabinetry. Again, I kind of covered this, doing in-context design without the assembly struggles, and then using that assembly for secondary operations. Maybe I'm adding holes at that level and hardware, whatever it might be. Then getting my bill of material there. And then let's see if there are any questions. I realize I left a whopping 5 minutes here, but again, I'm willing to hang out for as long as you guys are. So Jeremy, were there any questions?
There was one that came up a while back, and give me a second.
About the projected curve?
The projected curve, yeah.
So the projected curve is a little bit different. I did see that. I did happen to glance at that as well. So projected curve, for those of you, somebody asked about when I was doing the Derived Sketch or the convert entities, if it's kind of like a projected curve. It is and it isn't. What I'm doing with even a convert entities is basically copying a sketch entity from something else. A projected curve is actually going to take two different edges, lines, whatever, and kind of create a crossroad of where those two are going to hit. Right? That's kind of what the projected curve is. That makes a little bit more sense, hopefully.
Just got a question pop in, if you saw that or not. When
About
you
the
do
hardware?
add hardware holes, how does it affect your cut list?
All right. So, and this is where, okay, and I'm going to be honest, guys. Everybody's going to have their industry standards, right? Everybody's going to determine how they want this to happen. So I'm going to go back to I'll just go back to my frame of plates here, right? So if I'm going, and again, this is going to be personal experience, not necessarily what everybody's got to do, because everybody's got to do their own way of doing this, right? So if I were to do this, then I realize that, at the end of the day, my guys are going to have to bolt on those plates and everything else again. I may choose not to put the holes here. I may choose to use one drawing as basically my cut list, much like what it says. Here are my sizes. Here are the lengths you need to cut. Here are my bounding areas I need for the plates, so on and so forth, right? And then use the assembly to create the holes that I need and add hardware. So that bill of material would be showing where the holes are located. So I look at it as a secondary operation. Right. I've got so I'd look at it as a secondary operation. So just to quickly go over that, I'm just going to make an assembly super quick. And then I'm going to show you what you get for a bomb. But you can also have an indented bomb at the assembly level as well. So I'm going to go ahead and just pop this in. Not going to get super fancy here, but see, I'm going to put holes in this thing. So I'm going to go in. I'm in the assembly level. I'm going to go ahead and where do I want that? Let's go ahead and just add some holes. We're just going to do a simple hole here. I'm not going to get fancy. Simple holes. Let's see. Hold on 1 second here. And actually, this is a great place to mention this. But I'm going to go ahead and we're putting a simple hole. You've decided there. You know what? I'm going to backtrack, guys. Sorry. I'm going to go back in. I'm going to say I want to use a hole wizard. There we go. And I'm just going to do a simple hole to this. Simple straight hole. Drill size may not be the right size, guys, just being honest. All right. I'm going to go positions. I'm going to pick on a face here. Yeah, it's a pretty small flipping hole, but that's all right. All right. So I'm going to have a hole there, so on and so forth. Something I need to be aware of in the type is basically what's called a feature scope. And the feature scope says, how is this going through? I want to make sure that instead of doing this, I can go ahead and pick on. Oh, actually, it would just take the entire frame. All right, good to know. Never thought about that. All right, going my way. All right, so I've got some holes. I'd go ahead and add some fasteners. So should be able to just get a smart fastener in here somewhere. Insert. Insert smart fastener. There we go. Smart fastener. My toolbox is, and I know why my toolbox isn't present. Anyways, my toolbox isn't present because of, like that easy. My toolbox isn't present because it's on my D drive, and my D drive is giving me problems here. So just for grins, I'm going to insert a different part just for the fun of it here. And let's go to, we're just going to insert anything. Why not? Don't have to be picky. Yeah, we're going to insert the fence. All right. Granted, I realize these don't go together, guys, right? But if I talk about the bill of materials here, I'm going to go in, and you can, by the way, do bill of materials right at the assembly level. You do not have to create a drawing, but just for grins, I'm going to go ahead and insert. We're going to go tables, bill of materials here. Now this is a bill of material. I'm going to go ahead and just hit OK. All right. Now, there's my two items right here, but watch. I'm going to pick on this. You go to indented and say I want a detailed cut list. Then you get both. So you can have a cut list and then an assembly saying here's all my hardware, keeping it separate. Or I can do an indented BOM. One of those, either one of those would work. All right, accurate to assume, let's see, at the beginning of the webinar, going over the library files, accurate to assume that you had to download from the Solidworks website all your Weldment profiles. The answer to that is no. You do not have to download them. They're actually already here underneath the design library. Solidworks content, Weldments. You just have to extract them. So these all have been around for eons. They just need to be extracted. If, again, you're looking, you can always download your own and make your own library. You know, again, just keep an eye on the formatting that the Weldment profiles folder uses to make sure you don't have problems accessing your profiles. But you can also make your own. I'm hoping that answers that question. Let's see. I use a different technique offsetting planes. Can you show the offset plane command? Interestingly enough, I'm going to go back here, and you guys are going to laugh. Well, you may not laugh, or I'll be honest, you may not laugh about this. Actually, all I did to create my offset plane is I went to features, I went to reference geometry plane, I went ahead and defined the distance off my front plane, and I named it. So there might be a cheat compared to that question on how to make that. So I made it the old school way. Sometimes you guys should know, even if you're new learners, that there's 5 ways to do the same thing. Just all depends on how you get there. Sometimes, yes, you can hold control and drag the plane as well. I find I struggle with that, which is actually funny because I shouldn't. So there's a few things I tend to do old school just because I know that they're tried and true, as opposed to doing all the fancy, you know, it's like I know like Mark Johnson from Solidworks probably cringes that I do not use mouse gestures. All right. Can you pull a separate part into Weldment? Actually, question. You can pull components in. So say I had a part that was a foot pad for these. That's a great question. And again, I'll go as long as anybody hangs out. So if you need to drop off, guys, thank you so much for coming. If you want to hang out, I love the stump the chump, so I'm all good with this. All right, so for friends, I'm just going to grab myself, and I'm just going to create a little plate here. I don't want to do that. Let's do that. This is where I'm going off the hip here, guys. So if I goof it up, it's all on me. All right, just going to get a rectangle going on. We're just going to make a little, we'll just say it's 6 by 6. I don't know if it's big enough, but we'll make it work, right? And I'm just going to tell these two to be equal because I like building intelligence into things, and I'm just going to make it into a plate, right? Simple as that. I'm going to save it. And I'm going to call this foot plate so I know what it is. Now, when you do this and you're bringing it apart, it is a little bit more difficult than just mating inside an assembly. So there's some things you have to watch for, but you can certainly do it. All right. So I'm going to come back here to my part file, and it's called Insert Part. So a couple things I'm going to look for. I'm going to go ahead and I'm going to browse. I'm going to pick on that foot plate here, and yep, it brought me, let's see. What is it looking for? Why is it looking for that? There you go. That was weird. All right, there's my foot plate. Now, before I do anything, I got to decide what's coming in, right? So I'm going to make sure I've got the solid body. I probably want the planes. The planes are going to help me possibly locate my plate in a position. I can bring in any absorbed or unabsorbed sketches. So any sketches that are out there I might be using for reference, or anything that was absorbed into making my plate. Any whole wizard information, I might want to bring in the material, but probably most right here is locate part. I'm going to turn that on. I want to locate the part from move copy body. Okay. And I'm going to go ahead and hit OK. Now by default, this plate's going to go wherever I built it. And you can see what's going on, right? It's sitting in the middle of my part. Notice I've got this locate part. Now by default, I believe it goes into what's called translate and rotate, right? So I can turn around and give it a definition of, okay, I want you to go down, a negative direction down in Y to get it there. I can also rotate it around, but what I'm going to do is use constraints. This is the same thing as mates. Notice it's much simpler out here. It's not as definitive as, with mate and path mate, and, all that stuff. But I could certainly say things such as, all right, guys, I want that face. I'm going to rotate around here to get that bottom, and I want that face to be coincident. And I'm going to go ahead and hit add. And then maybe I've got a mate between this face and this face. I don't want it to be coincident. Maybe I turn around and say I want a dimension of 2 inches off of that. You can see I can pick on that and flip the dimension, whatever it might be, add. So I can add mates to put it into place as well. And that's how I would add a part. Would the inserted part show in the drawing bomb or cut list? Absolutely. So if I take a look now, there is that body right there with the foot plate. So anything, so yeah, the cool thing about this is if you have a file that you use over and over again, maybe this thing's got wheels, right? Maybe I've got a part file that's just caster wheels. Maybe I download it from MasterCar or whatever it might be, right? I can over and over and over insert that information to here. So when I go ahead and go into the drawing, let me go ahead and just save this. And hold on, let's go into the drawing right there. Boom. Let me update the drawing. So notice here's what that doesn't have. I don't have a description, but if you have information in here, so again, that goes back to the property. So right now, guys, be really clear about this. All that information at bottom is pulling from these properties. So if you take a look, you'll notice here's the summary. There's my body. I've got nothing here, but I could certainly come in and say description and say this is my foot pad. 3/16 inch thick, whatever it might be. Other cool thing about this is when you're out here is that I love these other tabs here. You actually have a summary. So this actually shows you every property that are out. Is this how you would build a trailer? I would say yes as well. So Jeremy's saying, yep, building a trailer. Again, keep in mind though, that more complex it is, the more resource hog it's going to be. So does it make sense to build, say, the frame with the panels as a part? And then at the assembly level, here's where I'm inserting the kitchen table and where the stove goes, where the shelving goes. I could certainly do that, especially if you have components that you're using over and over. I may be able to do that. All right, any structural weldment, I could use weldments and sheet metal. Could that footplate description come from the footplate part? Only if the footplate part was already, and I have to test that theory real quick here. So let me check something super quick. That's a great question. So if I go back to that foot pad right now, so right now that foot pad is just a part file. It's not a weldment or anything else like that, which means it doesn't have those properties. So let's do a little test here. I'm going to open up this foot pad. I'm going to do two things. I'm going to go into my properties here. And we're going to try two different things. I'm going to add a description here, and we're going to add three different descriptions because this will tell us where it's pulling from, right? So I'm going to say the value here. We're going to call this test 1, description, custom. I'm going to go to configuration specific to just make sure it's not pulling from there. We're going to go test 2, config specific. Now, because it's not a weldment, right now I don't have those. But at any point in time, I could certainly come in and click on weldment right here and make it a weldment without doing anything else. Now, I have not found a ton of uses for this, but for this theory, I think this is a great way to look at this. I'm going to go to the properties now. We're going to add the description here, and we're going to call this test 3 cut list. So the theory says, where is this information pulling from? Now, because I already pulled in that other part, I may have issues with that one. So just for grins, I'm going to save this. I'm going to go back out to my frame. Where the heck is my frame? I've only got 15 of these frames, guys. There we go. Let's see what she does. Okay, that's the foot pad. Oh, because I added that. I manually added that information. So let me, in theory, go ahead. I'm going to delete this. So now that we know we've got that in there, I'm going to go ahead and save. I'm just going to insert that part again. I'm not going to bother mating it, but I'm going to insert part. We're going to take the foot pad, foot blade here. All right. So I'm not going to bother locating the part. We're just going to X out of that. Now let's take a look at these properties. Let's see what she pulled. And it does not pull. Property description. Yeah, it's not pulling. So I want to thank everybody again. I mean, that's kind of cool. I still got about 50 people hanging out. Either that or you guys are all sleeping and haven't been paying attention. That happens too. So again, guys, thank you so much. I had a pleasure doing this. I hope you guys got a little bit of excitement out of Weldments, as crazy as it sounds. Take care.